Okay, so hello everyone. My name is Gonçalo. I'm from WhatIS. I'm a data scientist there, and I'm here to present a brief overview of our company and our NILM algorithm. So we are a data analytics company. We don't have any hardware of our own. We work with any energy consumption data that is able to be accessed through an API. We also work with sensors and meters and actuators that have an API. In order to access our services, you have two options, either through an API of our own as a service, or as using our visualization layer, which is basically a white label platform that you can customize to your own liking. So I've loved the talk so far, but our scope in terms of WhatIS is currently at the minutes to hour resolution. So deep learning is really interesting, but it doesn't really work at that resolution so far. Or at least we hadn't had any breakthroughs there. So analyzing the cost to sample rate, these graphs here that I've presented, we estimated our costs in terms of resolution to be increasing with the resolution, but the infrastructure cost per client lowers as you get more clients. But we are a really small startup, so we have to balance there the investment on our end versus the service that we can provide. So we are targeting the hour to minute resolution in terms of time, but we recognize that different companies and different applications require different services. For instance, SME may require an energy analyzer that works on the kilohertz frequency, but a utility like EDF has free data for 10 minutes. So each client has a different need, and of course that translates to a different cost. So I have a tease here for you. The first one to guess the load at acceptable resolution wins. I'll buy a beer. That's acceptable, I think. So this is a half an hour, more or less. This is 15 minutes, and this starts to lower to, I think, 5 minutes to 1 minute and to 1 second. Everyone here likes to present 1 second and hertz, but yeah. That's not our reality as we face as a company. So it's really easy as a human, to identify this as a dishwasher with 1 second, but not half an hour. Half an hour, everything looks the same. Everything is a triangle, or a dishwasher, or a washing machine, sorry. Our algorithms also love classifying washing machines. Yeah. Our NILM algorithm also loves washing machines. So everything he doesn't know is a washing machine. So that's a common problem there. But yeah, we're trying to eliminate a few false positives, and we're working that. But it's really difficult with low resolution data to really get the information that we need. So how can we get that information? Well, we need other sources. So energy is just one source of information. If you know the location of the home or the place, you can know the temperature. You can have satellite information. You can have, I don't know, taxes information. It depends. It helps you classify the NILM and the services that you can provide. I have an example here of our, let's call it consumption learner. And it's this in the y-axis, we have the interval of temperature. So this is Portugal, so warm, sunny. Minimum temperature 24 degrees, maximum temperature 34, something like that. And then in the winter, the minimum is 15. So be jealous. And that's why we don't need really ACs and heaters. So it's a complicated market. So because the savings aren't really that interesting. But yeah, moving along, the keynote here is you need other sources of information when working with such a low resolution data. And that's what we try to integrate. We have a couple of services that we already developed, and we use information available through, as I mentioned, taxes, LiDAR information, which is laser radar something, which detects the envelope of the building, the shape, the volume, and it helps us to develop our own products. So kind of a smooth transition there, not really. So our residential platform, where we use NILM to identify the equipments, as we show there. We also try to quantify into savings and energy efficiency measures. So that's our mantra, to work the information to provide some sort of savings to the end user. That's the goal always. And we have a remote energy audit service for technicians. For instance, we work with a utility that sends their technicians to the client's home, and we do an energy audit remotely. And we complement this information with a NILM analysis of the smart meter that they install for 1 month, for instance. And we complement that information to produce a 3-page report that can indicate savings and investments. We also use it to project PV installations and how it impacts the consumption. And in terms of future, we're looking at demand-side management using, again, NILM to do the usage pattern recognition. So we have a few customers so far. I think it's going well for us. Let's hope it continues to be this way, and we'll grow and be here the next year. Thank you.